All right, let's dive right in. Welcome to The Explainer. Today we're embarking on a continuous, unbroken voyage deep into the Buddhist constellation. We are going to look at an absolute marvel of galactic engineering, Caldwell 45, which you might also know as NGC 5248. Now, we aren't just going to look at this galaxy from the outside. We are going to perform a literal cosmic zoom. We're going to start at the outermost edges of its halo and plunge straight down into its very heart to understand exactly how this massive galactic engine works.
But before we begin our descent, let's just take a second to wrap our heads around the mind-boggling scale we're dealing with here. 69 million. That is the distance in light years from our telescopes right here on Earth to Caldwell 45. To put that into perspective, the light hitting our lenses today, it left this galaxy right around the time the dinosaurs were going extinct. Yet despite being 69 million light-years away, modern astronomy allows us to dissect its internal machinery with astonishing precision. So, let's start our zoom with the macro view, looking at Caldwell 45 from the outside in.
Section 1. A galactic masterpiece.
So Caldwell 45 is what we call a grand design spiral galaxy. Basically, that means it's got these really prominent, well-defined, and beautifully symmetric spiral arms. But what makes Caldwell 45 a particularly amazing subject for astronomical study is that its spiral structure doesn't just exist on one level. It is continuous across an incredible 2 orders of magnitude in spatial scale.
And you can see exactly what that macro scale looks like right here. If you look closely at this R-band view, you'll spot these faint speckled edges. Those are the weak outer arms, and they stretch out across a massive 15 to 17.2 kiloparsecs. This faint outer disk is our starting point. It's the beautiful sweeping exterior of the galaxy. But sweeping outer arms don't just spin on their own, right? They have to be driven by something deep inside. So we're plunging deeper, past those faint outer arms to find the mechanical heart, the central pump that's driving this whole grand design.
Section 2. The hidden cosmic engine.
Now, this is where it gets really interesting, because our entire understanding of this galaxy actually shifted completely. For years, astronomers thought Caldwell 45 only had this tiny, short bar at its center. But when they used deep imaging techniques, like this bright heat map style view, they uncovered a hidden monster. That glowing central structure is a prominent stellar bar with a semi-major axis of approximately 7.1 kiloparsecs. This giant stellar bar is embedded right within that fainter outer disk we just looked at, and it basically acts as the primary gravitational engine of the entire galaxy. Which, of course, brings us to a huge question. How exactly does this giant 7.1 kiloparsec bar physically fuel the core of the galaxy? I mean, every engine needs a fuel line, right? It needs a way to pump raw material from the vast outer disk down into the central combustion chambers. To answer that, we have to track the fuel. We're zooming in again, focusing on the dynamic, inward-flowing rivers of gas.
Section 3. Rivers of gas.
Take a look at these side-by-side views. This is where the mechanics get absolutely fascinating. On the left, those dark, swooping lines, those are grand design dust spirals. These concave dust lanes sit right on the leading edges of the stellar arms. Now look over at the right image, where the molecular CO gas is mapped out in those contour lines. Notice how perfectly they match up? The dust lanes directly align with the massive molecular spiral arms. The dust is essentially outlining the shock waves where gas is being compressed, creating literal channels or rivers flowing inward. Let's break down the actual physics of these rivers. We're not talking about gas just lazily floating around the center, no way. The gravity of that giant stellar bar we just talked about is actively pulling on these massive molecular CO arms, creating strong non-circular streaming motions. The gas is being funneled inwards at incredibly high speeds. We're talking between 20 and 40 kilometers per second. And because of this massive flow, a staggering 10 to 11% of the entire dynamical mass in the central 1.5 kiloparsecs is just pure molecular gas, just waiting to be ignited. So we have the engine and we have the high-speed fuel lines. Let's zoom in even further to see what happens when all that fuel pulls together inside the combustion chambers of Caldwell 45.
Section 4. Pearls on a cosmic string.
Checking out the CO intensity map of just the inner kiloparsec, you can clearly see how those massive eastern and western arms we were just tracking physically dump their payload right into the central regions. The gas pools and clumps up into these incredibly dense, high-intensity zones shown by the darker shaded regions. This pooling sets the perfect stage for some of the most violent, spectacular physics in the universe, a starburst. Now, the crazy thing is just how organized all this chaos actually is.
Astronomers like to call it the pearls on a string scenario, and it basically happens in 3 distinct steps. Step 1, the stellar bar funnels the gas inward at high speeds. Step 2, that gas crashes into specific overdensity points. Think of them like traffic jams in space, right where the spiral arms meet the central rings. And step 3, that immense compression rapidly converts the gas into brilliant young superstar clusters.
Thanks to advanced adaptive optics, we can actually see this building in real life. See those bright, glowing dots labeled SC12, 13, and 14? Those are the literal pearls on our cosmic string. They are incredibly bright, ultraviolet-emitting superstar clusters. The inward-flowing gas has been ignited by the bar-driven spiral density wave, creating these massive pockets of intense starburst right along the inner dust spirals.
And get this, Caldwell 45 doesn't just pull this off once. It actually has twin combustion rings. There's an outer star-forming ring at about 370 to 400 parsecs out from the center, and an even smaller inner ring right down at 100 parsecs. Both are totally packed with these bright star clusters and HII regions. But remember, starbirth is a violent process. These young stars produce intense stellar winds and eventually go supernova. This massive release of energy incredibly efficiently clears out the remaining gas in just a few million years, which prevents the galaxy from burning through all its fuel at once. It's essentially a perfectly self-regulating machine. So we've now traveled 69 million light-years. We've seen the 15 kiloparsecs outer arms, the massive bar, the gas rivers, and the explosive starburst rings. Now, prepare for the final zoom as we step into the dead center of Caldwell 45.
Section 5. The Quiet Eye.
So using those same advanced adaptive optics, astronomers were able to peer right through the dust and capture this map of the very core. Just look at that tightly wound, interlocking spiral structure radiating from the absolute center. This nuclear mini-spiral spans a mere 100 parsecs across. Remember, we started by looking at arms stretching over 15,000 parsecs. The fact that this perfect spiral shape persists continuously down to this microscopic galactic scale is exactly what makes Caldwell 45 such a true marvel.
But here is the ultimate twist of our cosmic zoom. Are you ready for this? The actual nucleus is completely quiescent. It is totally inactive. Despite this massive stellar bar acting as a giant pump, despite rivers of gas flowing inward at 40 kilometers per second, and despite a surrounding hurricane of exploding supernovae and starburst rings, the very eye of the storm is entirely dead and quiet. The fuel never quite reaches the supermassive black hole that likely sits at the exact center.
Which leaves us with a pretty fascinating final thought to chew on. By unraveling the mechanics of Caldwell 45, we aren't just looking at some random, distant anomaly. The Milky Way is also a barred spiral galaxy. So what does this highly efficient, self-regulating cosmic engine tell us about the life cycle, the past starbursts, or the future evolution of our very own galactic home? It's a humbling reminder that the universe isn't just a collection of static images. It is composed of active, churning, beautifully structured machines. Thanks for joining me on this explainer, and keep your eyes on the stars.